I have just shown you how to measure the velocity at one spot, but most of the times we are not interested in the velocity at one spot in the airway. We are interested in the average velocity over the entire cross-section of the airway. So now I will show you how to perform the moving traverse air quantity survey. The survey is done by moving the anemometer up and down, and cover the entire cross-sectional area of this airway, and then the velocity we calculate is going to be the average velocity over the entire cross-sectional area. Because the operator, me, has to stand in this airway, that will cause some interference to the airflow. That's why we need to use this extension rod. So to make sure this anemometer is at least 1.2 meters away from the operator. Normally, we don't hold this and move it up and down. We have to use this extension rod. Also use a proper length of the extension rod so you can reach the bottom and the top of the airway as much as possible. The speed of the traverse has to be slow, normally at a speed of less than 0.2 meters per second. So that is about 5 seconds per meter. This is about 1.7 meter wide airway and about 2 meter high airway. What I normally do is I draw a line at the center and draw two more lines on the left, and draw another 2 more lines on the right. This will roughly divide the airway into about 6 sections. Well, I will use these lines to guide my path of the traverse. If you have a wider airway, you will need to have more of these lines because you want to have more passes so that you can cover the entire cross-sectional area of this airway. To start the measurement with this mechanical anemometer, I will lock the anemometer and press the reset button. I will start from one corner and unlock the anemometer and start the stopwatch. And I move this anemometer up very slow, less than 0.2 meter per second. And then move it down. When I move it down, because I have a line there, I know where I have to move it down to. And then move it up. Down. Now down to the second line. Up. Now pretty much I'm in the middle of the airway. I want to turn myself so I have enough space to do the second half. But when I turn it, make sure I do not turn the anemometer, so the air still flows in the correct direction. Up. Down. Up. I'm probably moving too fast just to demonstrate how it is done. When you do it, make sure it's not too fast. And the last traverse, up. then down. I want to finish the reading at the other corner of the airway. So I prepare my hand, and so once it's down here, I can lock it and stop the stopwatch. Let's look at the reading. The 1000 dial didn't show anything. The 100 dial shows 300, and the large dial shows 33. So 333 feet, and we have 246 seconds. So 333 feet divided by 246 seconds, and then multiply by 60. That will give us feet per minute. It is 81 feet per minute. The same thing, we go to this correction chart. Here it says between 70 and 90, we need to add 15. 81 plus 15, that's 96. So the actual airflow velocity is 96 feet per minute. One more thing I want to mention is when you are doing this traverse, if you have other people also in the airway, make sure the other people stand downwind from a distance, not upwind, okay? So other people will need to stand downwind. If we are doing this moving traverse air quantity measurement using this electrical anemometer, we just need to click the next test button. So a new number shows up there, and then position the anemometer at the right position and make sure the air is passing the anemometer in the correct direction. And then I click the middle button to start. Same way as using the mechanical anemometer. So I will just quickly show this. So you go up, down. Well, I'm doing so fast. You need to do it slow. Up, down, up. You have to turn because you want to have some space. Up, down, and up and down. And at the corner, stop. Also, you need to make sure you're not moving this so fast. The speed has to be less than 0.2 meter per second, and the entire time of finishing the traverse has to be more than 1 minute. To look for the average velocity, just we go to stats, and the current measurement is 58. The average is 0.76 meter per second. With the average velocity, we can then measure the width of the airway and the height of the airway to determine the area. Velocity by the cross-sectional area, we get air quantity. Now I will show you how to log the data for the moving traverse air quantity survey. Here is a table that is commonly used for recording the data for 3 repetitive moving traverse measurements. In this table, you have the date and time that you have performed the measurement. And also, this is the ventilation survey station name, which indicates the location where you have performed the measurement. The number corresponds to a specific location on the mind map. Normally, we perform 3 measurements. So for each measurement, we have the stopwatch reading, we have the anemometer reading. In this case, we assume that we are using this mechanical rotating van anemometer. After each measurement, we calculate the velocity before correction. So using this data, the anemometer reading 311 divided by the stopwatch reading 100.2, we get the velocity in feet per second. And the result multiplied by 60, we get the result in feet per minute, equals to 186.2 feet per minute, which is this value, we will do the same calculation after each measurement. Then we will correct the velocity based on this correction chart. The first value, 186.2, lies between 100 and 200, and the correction factor is plus 15. So the corrected value is 186.2 plus 15, which is 201.2 feet per minute. Using the same method, we can correct the readings for these two values. Once we get this corrected velocity value, we will need to calculate the errors of the three measurements and make sure the error is less than 5% to ensure the accuracy of a measurement. Otherwise, we will need to perform additional measurements until the error is less than 5%. Here, we use the coefficient of variation, CV, to quantify the error. The coefficient of variation is calculated by calculating the mean velocity and then calculating the standard deviation, and the standard deviation divided by the mean velocity, we get the coefficient of variation. So in this example, the mean velocity equals to 201.2 plus 196.8 plus 205.1 divided by 3, that equals to 201 feet per minute. And the standard deviation can be calculated using this equation. It equals to square root of 1/3 multiplied by
the first velocity value, 201.2, minus mean velocity, 201 square, plus the second velocity value, 196.8 minus 201 square, plus, and the third velocity value of 205.1 minus 201 square.
If we do the calculation, it equals to 3.39. Thus, the coefficient of variation equals to 3.39 divided by the mean velocity of 201. 201 equals to 1.7%, which is less than 5%. That indicates that our measurement is pretty consistent and the data is accurate enough to be included in the report. If you get a result that is larger than 5%, then we will need to perform additional measurements until we get the coefficient of variation less than 5%. On this slide, I want to summarize the key points when performing the moving traverse survey. Firstly, the operator should be more than 1 meter away from the anemometer. Thus, we always use an extension rod. If we have more people standing in the airway, these people should stand downstream to reduce measurement interference. And we should use a slow traversing speed, less than 0.2 meter per second or less than 15% of the airspeed. The time used for the moving traverse has to be more than 1 minute. It doesn't need to be exactly 1 minute. It can be 2 minutes, it can be 5 minutes, depending on the size of the airway, but it cannot be less than 1 minute. And we will need to repeat the same measurement for 3 times until we get the error that is less than 5%. Lastly, I want to show you another video in which I'm performing a moving traverse air quantity survey in a large airway using an electronic anemometer. Thank you very much for watching. This is Dr. Xu. If you find the video is useful, please subscribe, like, and share it to others who may also benefit from learning more mine ventilation skills. I will see you in the next video.